Hello, Flat Earth researchers, debaters, and debunkers. The belief that we live on the outside of a spinning globe comes down to assuming that the horizon is a curve. This is the fundamental interpretation of our observations in the real world that are converted into this model of a globe Earth, in which it's assumed that the horizon is the limit of where we can see, and beyond the horizon is where the surface of the Earth begins to curve down and away from us. And so we get images such as these windmills here that are presented as evidence of curvature. So we're going to scrutinize this evidence, and we're going to talk about some of the assumptions that go with this and the contradictions with reality and with indeed the model. So let's first understand that the model is a concept. The globe Earth model is a concept, or any model that you wish to come up with is conceptual, because we really don't know where we are and what this place is, whether it's contained or not in open space. There is nothing that we really know beyond the land and the sea that we experience around us. And we do indeed experience the world as being a stationary, level plane as far as we know. Are there limits to it? We don't know. Is there a dome? Who knows? What we do know is that the geometry of perspective, when we are making observations in the sky, which becomes a dome or a hemisphere, has been translated into an imaginary curve, when in fact the surface is level and it's a dome of perspective that we can perceive when we see celestial objects going from one horizon to the other. It doesn't actually matter how far we can see across the surface when it comes to this dome of the sky that we perceive. That's just that's just perspective being described in geometric terms, and the distance to the horizon in the sky is of course far, far greater than the distance that we can actually see across the surface itself. That's kind of irrelevant. Yeah, the distance that we see across the sky. For example, I'm here on the equator, pretty near the equator. I can see Polaris, or the North Star, near the horizon, and I can also see the Southern Cross. So my celestial horizon, my celestial sphere, is vast, thousands of miles across. But of course, being on the surface of the Earth, I can only see a few miles in either direction across the surface. And that's not because of any physical curvature. That's just because of perspective. Now, one thing that anti-flat earthers or globe Earth defenders do understand is that perspective is a change in angular size. Basically, things appear smaller as they get further away. That's perspective. And yes, but this of course applies to everything in our view. And this is indeed what causes this apparent convergence. Now, if you can imagine being in a place where the surface is transparent, or you just don't have a surface, then perspective still applies. You're still going to have your personal horizon. And this is the thing we're going to see, that the horizon is always at eye level. It's always at our eye level. And the confusion occurs when people know that there are one or two ways to interpret the word eye level. And then so when it comes to talking about what we see and this alleged horizon drop that is supposed to happen if we are on the outside of a spherical Earth with a fixed geometry, then yes, we should see the horizon drop. And so then we are presented with evidence of the horizon dropping, and we'll have a look at that in a minute. But first, let's look at these windmills and some of the contradictions. Let's first look at this particular photograph that was sent to me in defense of the globe Earth belief. Now, you could at first look at this and you would say, yeah, that does seem to be curving down there. Those windmills are getting down some kind of curve, it looks like. But of course, as we said, this is this difference in angular size. They're all getting shorter, not just from the top, but from the bottom too. They are shrinking proportionately. This is what we have to keep in mind as well. And what we can actually do is zoom in. You can see the yellow here, and there's a section that sticks up above the water, and then there's a join there. Okay. Now this one on the right here is in front of the horizon. We can see there's a bit more distance to the horizon. This one appears to, the next one down appears to be on the horizon, but now that we've zoomed in, we can see that this yellow part is still highly visible until this link here, and the next one further along is much shorter and smaller, but we can still see that that is sticking up just as much as the ones in front of it, and so it goes on. Of course, it becomes very blurred, but we can see here now, when we on closer inspection of the evidence, when you actually come to scrutinize it, that this one is in front of the horizon, and our horizon is at a certain distance because of our height above the surface. Now, what is quite true and accurate are the calculations of the distance to the horizon that we see on the surface based on our height. These are fairly accurate, so whatever the height is here of this photograph taken from the surface will give us a horizon at a certain distance. But beyond that, it's not curvature. Again, we've got to consider that if you're talking about a globe with a fixed, curved, spherical surface, then nothing should change. But what changes is our perspective. So what happens is that these are actually just on the horizon. Okay, so we can't see. It's all very, very compressed. The surface is so compressed here in the distance that we just can't make it out. But all of these are in the same place. They are sticking above the water the same amount, and they appear to be on the horizon now. And the same goes for this over here. Let's just bring this over a bit. We can look at these two towers here. This tower, whatever it is obviously closer than this one. And this is much further away, but it hasn't sunk down any curve. It's just a lot smaller in angular size, from the top, from the bottom, in all proportions. So, this stem here looks shorter, but that's just the angular size. It's not because it's being cut off or anything. Okay. So, as I said, this photograph was sent to me as evidence of curvature. Scrutinize the evidence, and you see that no, that's not. There's nothing going down. There's nothing being blocked or hidden by any curve beyond the horizon. You've got 1, 2, 3, 4, 5, 6 windmills that go, or wind turbines that go beyond this imaginary curve, but they are still all sitting on the surface. Now, let's have a look at another one which kind of highlights the irony. Here is what appears to be a very sharp drop between these wind turbines in the front and these turbines obviously further away, and that will be passed off as curvature. Now, there's a couple of things to consider. Again, we're talking about the height of the observer above the surface. That makes a difference to where the horizon appears. There is also always going to be distortion above the surface. This is, of course, where you've got fluctuating air temperatures, you've got waves and all sorts creating disturbance. So the image itself becomes distorted. You can call it refraction or diffraction, or whatever you like. But this doesn't mean that it's bringing things up from the curve. But as you see here, this when you look at this, it's like, wow, that's a dramatic drop. So all the way up until, from our viewing point up until the horizon, there's no bulge. I think there's a general consensus that we don't see a bulge in front of us. But consider this. If you're saying that what we see in front of us is this drop, well then someone on the other side of that, if someone was on the other side of those windmills looking towards us, then surely if we're seeing this big cliff, they would be seeing a bulge. Yeah? So that's all it takes, is just imagining it from another person's perspective. And already this is very dubious. This is not a result of curvature. We can also consider the distance between these wind turbines, which is usually something in the region of 300 to 500 meters. That's apparently the optimum distance. So we're talking about 300 to 500 meters. So what is assumed when this is presented as evidence of curvature is that we have a windmill in the background there that has probably, it's probably one at the most maybe a kilometer away from this one in the front, and you've got this massive drop of several meters. So if that's the claim, then someone should be able to go and see that horizontally, shouldn't they? This is again what comes up as a contradiction. It's laughed at when we ask for horizontal curvature. It's like, well, show us this curve on the horizontal, and your globe earth proponent will say, well, no, the surface is level as far as we can see, then it curves down and away from you. Well, okay, you're assuming that this massive drop is your curvature. Then let's see it. Let's see such a significant drop of curvature in a short space. You could even do this mathematically, and it wouldn't work for the observation we make here. But the trick with these images is, especially one like this, as the way we can see what's happened here, is that you can see from the foreground that this photograph has been taken at a very low level. It could be about 1 meter off the surface. So of course you have a lot of waves and turbulence and things going on the surface. But that basically, because of our low elevation when taking this photograph, then we do get a horizon that will only extend to our eye level. Okay, and then anything beyond that does appear to be cut off. Okay, so if we talk about this curvature that we should see, again, here's what should be a massive gap. If you're ignoring perspective and angular size differences over distance, and you're saying that this is curvature, then look at this massive difference between the foreground and background windmills, which are probably not more than a mile apart. Well, let's have a look at a photograph like this. And of course, we don't see this amount of curvature between these windmills here, do we? Here's a side-on view, and it's flat and level. It's only when you go down to a low level, as you can see here, we obviously in the foreground here it's been cut off, or this is probably been zoomed in. So this is a low-level shot that's zoomed in on a distant farm, and this is what's giving us this horizon line here, which appears to be a dramatic drop. So of course the other thing is that if you're saying that is the horizon, this hard line is the horizon, that's the beginning of curvature, and anything beyond that is going down and away from us, then all you need to do is look at another photograph like this, for example, where the horizon has come up with us and is much, much further away now because we've gained height. Okay, so the horizon has become higher. So again, consider that this ship or boat here should be at a lower elevation, really. Essentially, it should be down a curve from this windmill here, or from this windmill here, yeah? Do you understand? If we're looking across a globe Earth, then everything is going down and away from us. So this boat should be appearing lower, but it doesn't, because that's perspective. That's how perspective works. So the way we see the world is completely ignored in favor of this belief that we live on the outside of a globe. It does not fit reality, and it does not fit our observations. So let's now look at this horizon drop claim, even though we've already shown that the horizon doesn't drop. Let's just have a look at it and see how deceptive techniques are used to make claims that the horizon drops below eye level. So here's a photograph called Flat Earth Lies, Horizon Not at Eye Level in an Airplane. And this appears to be a photograph taken through a phone that has a theodolite app through which we can measure level. So what we have here is acceptance on the globe proponent's side, as it were, that the center of our field of view when we are looking straight ahead is our eye level. Okay, this is what we mean collectively when we talk about the horizon being at eye level. Now, of course, to conform with the belief that we live on the outside of a globe with a fixed geometric spherical surface, then the horizon would have to drop. If your assumption is that the horizon is curvature, the horizon must drop as soon as you gain height above the surface. So there is this general acceptance that the center of your field of view when looking straight ahead, that is horizontal or perpendicular to your vertical, down, up and down, then the center of your field of view is your eye level, or this line that you could put across, which I've done here, halfway across. Halfway down this image is where the crosshairs are, indeed. So, again, to emphasize, even the globe proponents accept that when you're looking straight ahead, your eye level view is a horizontal level view from the center of your field of view directly out. So you could have a laser pointing out or something like that. So whatever is in the center of your field of view when you're looking straight ahead like this should be at the same height as you. And this is where the deception comes about. It's the use of the word eye level. So here, as I've said, we have this common understanding of the word eye level view to mean exactly what we're seeing here, a photograph taken with a horizontal view looking straight ahead. But then the term eye level can also be used to just talk about height, your height above the surface, and that can be referred to as your eye level. And then what happens is, for the globe Earth proponents, is they say you can then point the camera at any direction you want. It doesn't matter, because they're talking about eye level being your height above the surface. They are no longer referring to eye level being a level, direct, straight view that is horizontal or perpendicular to your vertical. They are only then referring to eye level as height. And it's just deceptive. So, in this particular photograph, it's obvious what's happening here. I've drawn a horizontal line across this, and so this is indeed eye level. And we don't even worry about this 0.0 over here. We can see a 0.0, whatever, 0.1, a 0.2 degrees difference. So it's a very slight angle or tilt, or it could be going forwards or backwards. However, what we have, of course, is a lot of cloud. And in situations like this, when we are, as we can see, 33,000 feet high, then we're going to be above a lot of cloud and weather in general. And that becomes our surface. And we can easily see here that we've got a kind of fairly hazy view of the surface, but then this cloud obscures it. Okay, the cloud's higher than the surface, but we are higher than the clouds. So the cloud then becomes our surface up to eye level. And then we can see here that it tapers off and it's nice and blue up here. Okay, so we still have a horizon, but I think what's happened here is that it's been assumed that this point where the clouds begin, the bottom of the clouds in our view above the surface, has now been assumed to be the horizon. And of course, for example, we can just highlight that here with this photograph. Whether this is a real photograph, I don't know, or these aircraft have been superimposed. The background looks pretty real, but the point is that we don't have a horizon here. There's no, it's all just hazy. So there is no clearly defined horizon, simply because there's weather on the Earth. Okay. So then we are presented with images such as this pilot's eye view from 40,000 feet looking through a heads-up display and a horizon in the distance. And this comes with the claim that the horizon has dropped from eye level. Therefore, this is cited as proof that we live on a globe with a horizon that is fixed and drops below eye level. But what's happened here is the term eye level has a slightly different definition, because as we've already seen and has been commonly accepted, the eye level view is that horizontal level view from that person's height when they're looking straight ahead horizontally, perpendicular to down, the center of their field of view. That is eye level. Okay, but in this case, eye level is just talking about the height above the surface. And eye level, or that level, is represented in the heads-up display, or that term eye level is applied to this horizontal line in the heads-up display, and therefore we've got this drop. But all we have to do is stick to the original consensus on both sides of the so-called flat earth debate, that the horizon is supposed to drop from eye level, which has been accepted as being in the center of the field of view. So this particular photograph is 452 pixels tall. So what we do is we just go to the center at 226 and see where that is, and it's right here, 226. So here indeed is the center of the pilot's field of view, and if the pilot has held the camera to be horizontal, then what we have here is a horizon, an external horizon, at the pilot's eye level. Of course, it isn't at the level indicator in the screen, but this is, you know, this point is way above eye level, our actual eye level, but it's this point here that's been talked about as being eye level. It's a simple deception. This is the kind of deception from someone that clearly knows what we're talking about when we talk about eye level, or an eye level view, or an eye level horizon, and has deliberately created this strawman argument by referring to eye level as the green line on that screen. But it isn't. That green line isn't at the person's eye level, the pilot's eye level, or the camera's eye level even. Now, all of these things move around. The line in the horizon line will go up and down, and it will creep up towards the top here as you gain height, as your eye level, in that sense of height or altitude, increases. But what we also have here is right in the center there is the pitch indicator. So we can see that the aircraft is pitched up. There are also other numbers on here that will tell you the pitch. So the aircraft is pitched up, and that's normal, of course, when you're flying at high altitude and you're flying straight and level. You're actually pitching up in order to carry on going in a straight line. So physically, pilots fly straight and level. They don't go round any curves. And observationally, they observe a horizon at eye level. In fact, they are taught to use the horizon as a reference frame, and that is exactly what the horizon is. The horizon tells us how high we are above the Earth, especially when we can see other things in comparison. It never changes, it's always the center of our field of view, but when we compare it with other things in the foreground, we can see that our eye level is where the horizon appears. So this does thoroughly debunk the claim that the horizon drops. It actually proves that the horizon doesn't drop. The horizon isn't geometric curvature, it is in fact the way we see a level surface and the convergence in the distance due to perspective, and it is perspective that's been passed off as geometric curvature. As we can see, water here is level. And so just to round this off as another frame from a video by an anti-flat earth pilot claiming that the horizon is below eye level. Again, we have this horizontal line in the heads-up display. We have the flight path indicator on that level, so it's going in its correct direction. It's pointing up, as we can see, in order to carry on going at a level altitude. And here we see the cloud again becoming the surface of our field of view. But again, instead of referring to this arbitrary line, which could be anywhere, as eye level, just because we are talking about being at a certain height, if we again highlight the pilot's eye level by putting a horizontal line across the center of the field of view here, the image that we have here, assuming the pilot is looking straight ahead, then of course we see a line defining our horizon, lining up with our horizon. So in this case as well, even though this was put forth as proof that the horizon drops below eye level, it actually proves that the horizon is at our eye level, even when that horizon is just cloud. We can't see the surface beneath us. And this is the wonderful thing about this, is because you see how people have to deceive themselves and deceive others in order to cling on to the beliefs and the explanations that have already been set in concrete for us living on a globe, when really horizons occur in our eyes. They are a visual phenomenon regardless of the shape of the Earth. If there wasn't such a focus on horizons, then this wouldn't be a thing. But the fact that the globe fundamentally depends on interpretations of observations as being curvature means that they have to stick to this, because there is no physical measurement of curvature. We know that water is always level, and as we can see here, the curvature that was assumed to be between windmills is not there. We know that in reality, when we look at reality, there is no curve, and physically water is always level in the true sense of the word. Doesn't matter if you suddenly convert the meaning of level to apply to a globe and a certain distance from the center. Again, that's easily understood, but that's not our reality. Level being a certain distance from the center of a sphere or a circle is a concept that can be applied to a ball or spherical objects. It doesn't apply to the Earth, doesn't apply to our reality. And that's what the main challenge is here, is to discern between reality and beliefs or conceptual models. And understand as well that so-called flat earthers are not claiming an alternative model, not claiming that the Earth is a certain size or dimensions. The possibilities are endless, and that is what makes this exploration of our world so thrilling and exciting. It's not a foregone conclusion. Science hasn't got all the answers, and certainly not mathematicians, because they fail to see what we actually see and experience in reality, because they want to hold on to their belief in a model. Thank you very much.